All right, so today we're talking about solving problems with angles of elevation and depression. And this lesson is going to be very similar to 8.4 in that we are using the same principles. The most important principle, of course, is our best friend SOHCAHTOA, where S is sine, C is cosine, and T is tangent. And then the O is the opposite side, H is hypotenuse, and A is adjacent. So our goal for today is to be able to use angles of elevation and depression to solve real world problems, essentially. That being said, the most important thing we're going to do, well, I keep saying the most. One of the important things we're going to do today is we're going to be drawing pictures to represent word problems. And then once we have those pictures drawn and labeled, then we can use SOHCAHTOA in order to accurately solve for our missing sides and angles. So let's get right into examples. So our first problem says, at the circus, a person in the audience at ground level watches the high wire routine. A 5'6" tall acrobat is standing on a platform that is 25 feet off the ground. How far is the audience member from the base of the platform? If the angle of elevation from the audience member's line of sight to the top of the acrobat is 27 degrees. So, first things first, we would draw a picture, which thankfully they have already drawn it for us. So, what they're saying is we have our person sitting here in the crowd. We are trying to figure out how far away this person is from the base of the high wire. So that distance there. Now they tell us the angle of elevation is 27 degrees. So this angle right here in the triangle is 27 degrees. And we know the platform's going to be at a 90-degree angle. So second thing we have to do is they say the platform is 25 feet off the ground, and then the high rise or the acrobat is 5'6" or 5.5 feet. So if the line of sight goes to the top of the acrobat's head, then that distance from the ground to the tippy top of the acrobat is going to be 25 plus 5.5 feet. So 30.5 feet. So if we wanted to generalize this into a very simple drawing, I could draw a right triangle with my audience member here. Yay, happiness, acrobatics. 30.5 feet. 27 degrees. And then 90 degrees. And we're trying to find our unknown, which is this side of the triangle. Now that we have that drawn, we can go about solving this just like any of the SOHCAHTOA problems we solved last time. So first things first, I'm going to identify my 27-degree angle because that's what we're working off of. And we're trying to find this x side, and we know our opposite side. So I know I need to set up something in SOHCAHTOA that involves the opposite side and an adjacent side to the 27 degrees. So looking at SOHCAHTOA, the only one that deals with opposite and adjacent is tangent. So I'm going to write a tangent equation for this. So I'm going to say tan of 27 is going to equal my opposite, so 30.5 over my unknown. Now I can go ahead and solve this for x. So to solve this for x, I would multiply both sides by x, and then I would divide both sides by tangent of 27. So I'm left with x equals 30.5 divided by tangent of 27. Then do a little punchy punch in the calculator. 30.5 divided by tangent 27 equals, and we'll round and we'll say about 59 point, we'll just say 59.9 feet. All right. So we draw the picture, we label the picture, we decide what we need to use from SOHCAHTOA, and then we do some solve-y-solve. All right. So next question, we have at a diving competition, a 6-foot tall diver stands on top of a 32-foot platform. So we have a diver, 32 feet, 32-foot platform, 6-foot diver. The front edge of the platform projects 5 feet beyond the end of the pool. So 5 feet beyond the end of the pool. So the platform goes out about 5 feet. 5 feet. The pool itself is 50 feet in length. 50 feet. A camera is set up at the opposite end of the pool, even with the pool's edge. So we have our camera here. Camera. It's angled up, so its line of sight extends to the top of the diver's head. Okay, so diver. Okay. So I'm going to assume my diver is standing on the edge of the platform. We have to the top of that diver's head from that camera, and that the top of that diver's head should be 38 feet off the ground. What is the camera's angle of elevation? Okay, so now our missing piece here is X degrees. Okay. So I'm going to redraw this triangle. So what I was doing with that first drawing is just making literally every single, every piece of information from this problem. Now, sometimes you're not going to need every single piece of information, but that's fine. We want to draw that at the start anyway. So I'm going to pare down this into a simpler triangle. So we have our triangle. Our height is 38 feet, 90 degrees. This is our unknown angle, X degrees. And now our bottom length, they said that platform extends 5 feet over the pool. So our bottom length is actually going to be 45 feet. Okay. Don't know why I used a degree sign. We're just going to pretend that didn't happen. So we have our missing angle, and we have 2 side lengths. So I'm going to want to use whatever sine, cosine, or tangent, whichever one fits for this angle. So I'm trying to solve for this angle X, and I have the opposite and the adjacent sides. That's what I know. So knowing I have the opposite and adjacent sides, I know I'm going to end up using tangent, because tangent is the only one that deals with opposite and adjacent sides. So what I'm going to say is I'm going to say tangent of unknown is going to equal opposite, which is 38, over adjacent, which is 45. So now we have to use our inverse of tangent, or that opposite. So what we're going to do is we're going to do the tangent, the inverse of tangent to each side, or cotangent is another word for it. So we do that, that gets rid of our tangent. So we're left with x equals tangent -1 of 38 over 45. Then we punch that into our calculator. Second tan, little fraction, 38 over 45. And we are left with 40.179 feet, or C. All right. So, our next problem. Maria is at the top of a cliff and sees a seal in the water. The top of the cliff is 40 feet above the water, and the angle of depression is 52 degrees. What is the horizontal distance from the seal to the cliff to the nearest foot? Okay, so this one, they say the angle of depression is 52 degrees from Maria to this massively adorable little seal. Now, we want to know the distance from the seal to the cliff. So there's two ways to think about this when they give you a problem such as this. What we really have is we have two triangles, and the distance from the seal to the cliff is going to be the same if the seal's in the water or if the seal was up here. So you could just draw your triangle like this black triangle that I just traced out horribly, and be fine. Or you can do it like they did, where you kind of have this imaginary extension where you have two parallel lines, the line from Maria out into the abyss and the line from the seal to the cliff, because then you have this tangent that cuts through there, which means, let me see if I can clean this up a little bit, which means since we have that tangent in there, that means angle ACD and angle BAC are going to be congruent to each other, meaning they're both 52 degrees. Okay. Now that we've done that and walked through that piece, what we have left is a fairly simple, straightforward triangle. And so what I'm going to draw, I'm just going to draw that out. Ideally cleaner than what I just did. So we have our triangle. We have our seal in the bottom right-hand corner with a 52-degree angle. We have an unknown distance, a right angle, and a 40-foot cliff. Now, knowing all of that information, we're trying to solve for x. And the good news is we have our 52-degree angle. We have the side opposite, and we have the side that is adjacent to that 52-degree angles, which we've talked about it a lot today. Tangent is the opposite over the adjacent, so that is what we will be using in this case. So I'm going to say tangent of 52 degrees is going to be equal to my opposite, which is 40 over an unknown. So once again, I would multiply each side by x, then I would divide by tangent of 52, so I'd be left with x equals 40 divided by tan 52. Then I would do a little punchy punch in the old calculator. Tan 52, and I'd be left with 31.25 feet. So that seal has 31.25 feet to go to shore. Oh, it says to the nearest foot, so I guess 31 feet. Same deal. All right. Now, Luisa is in a hot air balloon 30 feet above the ground. She sees a landing spot. Well, I guess I should draw this. 30 feet up. We got our little hot air balloon. Hot air balloon. Back to the hot air balloon. Come on. There we go. We're just going to say that's our hot air balloon. We're happy with it. She sees a landing spot at an angle of depression of 34 degrees. So we'll just say 34 degrees. right there, 34 degrees. What is the horizontal distance between the hot air balloon and the landing spot to the nearest feet? So, or to the nearest foot. Once again, I could just use this triangle right here and say, okay, 30 feet off the ground here is still going to be 30 feet off the ground over that way. So 30 feet is 30 feet on both sides either way. Or what I could do is I could say we have two parallel lines, so this angle is also going to be 34 feet. So 34, 30 feet, 90 degrees, and then our unknown. So you could do it either way. Personally, I'm going to do it the first way we talked about just because I think that's easier. So backspace that a little bit. Okay, so our triangle we have drawn right now, we have 30 feet vertical distance. We have a 34-degree angle of depression. And then we have an unknown distance from the hot air balloon to straight above the landing area. So what I'm going to want to do is I'm going to want to do SOHCAHTOA of 34. So 34, I have the opposite side and I have the adjacent side, which seems to be kind of a pattern here. So tangent of 34 equals my opposite, which is 30, over my adjacent, which is unknown. Now we're going to solve this the exact same way as we did the last one, times x on both sides, divide by tangent of 34 on both sides, which of course leaves us with x equals 30 divided by tan 34. And we do a little punchy punch, little solvey solve in the old calculator. Divided by tan 34 equals 44.4768296, or 44 for those of you rounding at home. All right?